so I'm not sure. I don't.
All right, everybody, let's go ahead and get started for today. I'm going to pass on the geography game for today. There's a lot to sort of cover, and maybe I'll spend a bit of extra time on the announcements today, okay? All right, so yeah, there's sort of, I think we're getting to the point in the quarter where things will start ramping up in terms of the amount of work, like for the projects. So maybe just pay careful attention here because, I'll try to remind each lecture, but there is a lot going on. There might be easy to maybe miss a couple of things. Okay, first and foremost, there's a new office hours location for my office hours. They're giving me like a personal office basically, and I'm like have to use it for office hours. We're not allowed to use like 4109, which is where it was before. So for those that have come to office hours, it's going to be the same time, okay, Wednesdays and Thursdays, 1 to 2 p.m., but it'll be in the 3rd floor of the CS building, CS 3236, okay? You can actually see a map of the 3rd floor. When you get out of the elevators, there's a map like next to one of the hallways, okay? If you just look at that, you should be able to find it, but it's basically like down one of the like back corners in the CS building, okay? It's a bit far from the elevator, but that's where we'll have office hours, so please make sure to come to this room, not the old one. I'll try to have a sign in front of the old office hour room. Okay, the next thing is Project 2 checkpoint is due today. So if you've already finished Project 2, that's totally fine. You can go ahead and submit it right now as well, and just maybe mention in the pull request that Project 2 done or something like that. For the checkpoint, the main reason we even have it is just so people aren't like working on it in the last 2 to 3 days. You should have like some maybe plan of attack or some diagram or some like understanding so far of the code that you're going to be modifying. And I think most people, if you've done some work by now, we're pretty confident you'll be able to get it in the next week. But if there's some sort of like hint or something that we need to give, we'll look through those, I think, tomorrow and then give the appropriate sort of like guidance that y'all might need, okay? Next is Exploration Activity 1. So we had released this last week. It was part of the debugging lecture. We didn't get to it until Thursday. So hopefully everybody's completed it. If you haven't, we're somewhat loose with the deadline on this. Please just fill out the actual form. That was, I think it's linked on the website, and it's also part of like the lecture 6 slides. So let me actually open the website. You should be able to see it on the course schedule. Exploration Activity 1 should be here, okay? And it's just a Google form that you fill out after you do an activity with the debugger. Maybe we'll have that like hard deadline be tomorrow, and we'll check all the participation for the exploration activity tomorrow. And then finally, we're going to actually cover large language models next week. So we'll be doing, in-class activities and demos using GitHub Copilot and GitHub Copilot Labs. So please make sure you follow the instructions from the first week of class about getting started with GitHub Copilot, okay? You should at least like have it installed and like set up on VS Code before coming to class next Tuesday. Also, for those that maybe weren't here in the first lecture, you just really need to follow the resource GitHub Copilot student signup. You shouldn't have to pay. It'll be free if you use your at ucsd.edu account. And then there's also there's an extension that you'll have to install. So the extensions tab on VS Code, I don't know if this makes it, okay, it does make it bigger, is, let me get rid of this, we'll talk about this diagramming stuff in a second here. These like little blocks is the extensions tab, and you can actually just search extensions on here. You'd want to do like GitHub Copilot, and you should have, oh that's weird that it had an error, hopefully yours doesn't have an error. You should have a GitHub Copilot extension, okay? If you do get this error while it's searching for it, I'd probably just try closing your VS Code and reopening or something. Taking a long time to search though. Anyway, let me just do that right now. Okay, are there any questions about those announcements that I've just made so far? About any of these, Project 2, office hours, GitHub Copilot? Okay, here's the next thing, okay? So this is sort of like what's eventually going to be the final sort of project. What we're going to do in the final exam part of this course is just have presentations from the group projects, okay? So we're actually starting the whole process of the group projects now, even though it's like the start of week 4, because there's going to be sort of a few different checkpoints leading up to the final deadline, okay? So you can actually see the group project proposal assignment on the course website right now. So when you follow that link, or if you go to the course website, you'll notice that there's a new part of the left-hand pane here that says group project. If you just click on the actual purple part that says group project, this is just a bit of like an overview, some high-level requirements that are going to be required for the project. But then when you actually click project proposal, this is going to be the actual assignment that you'll have to work on that's due May 3rd, okay? So I think you have about 9 to 10 days to do this. What we're asking you to do is first get in teams of 4. I think we have 48 people that are enrolled in the class, so we should have like 12 even teams of 4. And you're gonna just spend the next like week and a half proposing, like thinking of 2 different project proposals, okay? So the idea here is that you've explored the code base a little bit, and you'll continue to do so for project 2, project 3, and in these in-class activities. What you'll be doing is proposing a new feature to add to the idle code base, okay? And over like about 1 month or 1.5 months with your team, you're gonna be working to implement that. But not just like, throw together this feature and have it be like functional. You want to, follow some of the principles that we have covered and will continue to cover. So stuff like code quality is going to matter a lot. Stuff like testing your code, documenting your code, diagramming your code, and then you'll eventually be doing a presentation on the code, which is also going to be part of like the final project component, okay? So one thing I want to mention about this is this. So we do have a few example project ideas. It should be a somewhat like sizable feature addition to idle, okay? And just to give you some ideas about like what kinds of features you should be adding, this motivating your project idea is going to be a somewhat important section to read. So I mentioned this before, I think in the first week, but idle is a super common IDE used by like novice programmers, people who are learning the code for the first time. It's like a common IDE used in like intro CS classes. And so one sort of idea or like line of ideas that your project can be about is how to like support people who are learning the program for the first time. Like what are some features that would be like useful if you were also, a novice programmer learning the program on this IDE. So, there's also this huge, advent of generative AI and large language models just in the software engineering space. So you can also take some freedom to maybe use, some like open source APIs, or maybe I think last year some people did pay a little bit for integrating some cool features, like for each like API request, they were paying like half a cent or, something really small like that. Feel free to be as sort of exploratory and as creative as you want with this. One idea here was like generating code explanations. So maybe we can have a feature, and this is, we haven't implemented this, this is just like a high level thought. Like maybe we can have something where you highlight some code and you can click a button that's like generate explanation, and it sort of describes the syntax and like the components of the code to a novice who is maybe confused about like what a for loop is or what the syntax of a for loop is like. So that's sort of like one type of motivation, is sort of like the educational aspect of it. If you're not able to sort of think of some idea related to that, you can also have a project that relates to like developer productivity or well-being, So think of like what we're doing for project 2 basically is taking an existing feature that's not so good, for example, and making it a little bit better, like how like VS Code has it. So this is another like type of project idea, but just make sure you do motivate your project proposals. You'll have to be coming up with 2 project proposals, okay? And each project proposal should be sort of like well thought out, and you should probably look through some of the code before finalizing your project proposal, because you're going to need to sort of describe how doable this project is. Okay, you'll probably want to give some estimate of like how much work is required, the extent of the code changes required. If you're going to be using some like outside libraries or frameworks, you might want to already have done some work on what are those frameworks or libraries that you're going to want to use. Okay, so we're going to have you submit these project proposals as a GitHub issue. Okay, so you'll actually find a new invitation to an assignment, a GitHub Classroom assignment, at the bottom of this document here, the group project, assignment document. So it's going to be like right now you have your own individual repository on GitHub Classroom. You're going to be having a group one where you and 3 other classmates are all able to like push and pull from the same GitHub repository. Okay. So let me actually just show you what I mean. Let me see if I can just make an issue right now. Okay, so I've just created this right now. It's just like a staff team repository. And so when you click on this, you should be able to see issues over here. I think I even showed an example of like the actual CPython code base. You can see actual issues for the open source project. These will be, so again, I click on this like issues tab here, the second from the right. And it'll be like different feature requests, requests for bug fixes, etc. So you're going to be doing something very similar. This is going to be, again, how you propose or submit your group project proposal. You'll actually just be making issue requests or making an issue with the project proposal. Okay, and you can format this in Markdown. So just like the setup.md file from project 1, you should format it nicely. You should maybe use some of these headers that I think we've sort of outlined in the document. Okay, the rest maybe you can read on your own. I won't spend too much more time on this. But are there any questions about what the group project is going to look like? Any questions about the deadline or deliverables?
Can you just say it one more time, the deadline for it?
Yeah, the deadline is going to be May 3rd. And actually, I was just going to mention this as well. All the sort of intermediate deadlines are already on the schedule. Okay, so you'll see like group project proposal is released today, April 23rd. You don't have to actually submit the proposals until next Friday night, okay? And then after that, we're going to take a look at the 2 proposals that you've created, and we'll say, okay, you should do this one because it's maybe a bit more manageable. It'll, have a bit more like educational value. If both of the proposals that you submit don't really make the cut, I guess we already have some like preset ones that we'll just assign to you, okay? But the goal is that everybody is able to propose their project and should be able to do it. Okay. Any other questions about the group project? Yeah, so after the May 3rd deadline, there's checkpoint 1, like almost 2.5 weeks later, so you'll have time to work on your own, make progress, and then we'll have more instructions about what to do at the different checkpoints. Any questions? Okay. Awesome. So one more thing that we're realizing is having maybe a bit more clarity for what to put in the design document and the process journal. Okay. So I think a couple of you, maybe a few of you have already submitted project 2. And I think if possible, editing what you currently have for the design document and process journal would really help here. So importantly, we don't want you to have to like add a bunch or take out a bunch, but it's more just like how to structure the document so that it's easy for us to grade and sort of like understand what you did. So for the design documents, I think having like high-level diagrams about the code that you're going to be like impacting or editing, a description of your code changes. I know this is already going to be present in like the files changed when you are able to like view a pull request and see the changes in the pull request. Having like a maybe plain English description of the code changes would be helpful. A justification of the code changes. Okay, so this is pretty important here. Make sure you there's going to be like a few different ways to actually get the answer for project 2, okay? If you already have an implementation, you should explore a couple of the other alternatives for how do you like pass some parameter from one class to another or something. and sort of see the different actual like implementations that you can have and sort of justify why you chose the one that you did, okay? Remember, we talked about like code quality, program quality when we were talking about the Python prompt, such that the sidebar automatically changes width. We already have a solution for project 2 that we think uses somewhat good code quality compared to the other alternatives. You should be having sort of the same consideration and justification in your project, okay? And then finally, instructions for future changes. Maybe you just want to have a bit of like a primer for somebody else who might be like working on this feature, who might be making changes to the code that you wrote. So maybe just any instructions or like pieces of advice or guidance for developers who will like take this on after you would be pretty helpful here. Okay? So again, if you've already submitted it, maybe just reformatting it to be these headers would be pretty helpful. Any questions? Yeah.
When you say submit, do you just mean like create a pull request on GitHub?
Yes. So anytime I mention submit for any project, individual project or group project, I'm specifically referring to making the pull request on GitHub Classroom, okay? And specifically for project 2 and project 3 and project 4 for the individual projects, there's like specific instructions to have like a process journal, a journal.md file and a design.md file, okay? So you're going to actually have 2 documents where one is the design document, one is the process journal. That's like part of the pull request, okay? So when we eventually grade it, we're going to look at these 2 documents and the code changes that you've made, which are already present in the pull request, all right? Okay. Oh, yes.
Do we have to create a new pull request if we make changes, or does that auto?
Okay, yeah, great question. Thanks for the reminder on this. So the question was like, do we have to make a new pull request, or does it automatically like take into account the changes? So you don't have to make a new pull request. You can just make another commit to the branch that the pull request is already there for. Okay, so like in project 1, you made a pull request that had setup.md changes to setup.md. Some of you got like a request to maybe like modify some stuff, modify some file paths of images, or just add some stuff to setup.md. You can just make those changes on your your VS Code, and then just make a git commit, make a commit to that same branch, and we'll be able to already like see it. I think I get an email when people make commits to their pull request. So you don't have to close the pull request, make a new one. You just make a commit.
So if you do 20 times, you're gonna get 20 emails?
I think it merges them all into one in a chain or something, but yeah, my phone starts buzzing a lot here. Okay, any other questions? Yeah, about design or process journal? Okay. Oh yeah, question.
For the description, or like for me, description, justification, like I feel like it could be repetitive. Is that fine?
Yeah, so I think for description of code changes, you just need to talk about what your implementation was. I think for justification of code changes, you can even compare it to some alternatives. Like, I consider doing this instead, but I think my approach is better because it limits the amount of like code that I had to add. Or I didn't have to change this class, I only had to change this small method or something like that. So in the justification of code changes, you might have to also explore alternative approaches and sort of recognize the pros and cons of those alternatives, okay? And it's okay if these arguments are not very clear or like super convincing. We're gonna be like learning throughout this project, and once you make an initial submission, we might get back to you like maybe you should actually use this approach instead, and then we'll talk about the different approaches, after the project is finished, okay? So don't worry if you're not sure what the best approach is. Try something, justify it, and then we'll talk about it after the deadline.
No, we don't need all of that by today, right?
Right. This is due a week from now. So this is due project 2 is due next Tuesday at midnight. And then remember, we have the 24-hour grace period, so you can submit it Wednesday at midnight without any penalty. You don't have to let us know. But yeah.
Wait, for today, how complete should it be?
Yep. Yeah, so I did mention this before.
Oh, I'm so sorry.
You watch the podcast. By the way, the podcasts are on the media gallery in campus.
Well, they are,
okay?
so I'm gonna look at it.
Okay. Awesome.
Do not answer my question.
Yeah. And also, the way it works for uploading the podcast is I have to actually like click something after like 20, 30 minutes after the lecture. If it's been a couple hours and I've forgotten or the course staff has forgotten, you can just make an edge post and say, can you add the lecture for today? And that'll just give me an email notification and I'll do it. Okay, for process journal, we've sort of listed out 3 key pieces. Again, if you've already submitted, you don't have to change like the content that you already have, but the most important part here is for the process journal, try to like self-identify the sort of individual components of completing the project, okay? So maybe one component was understanding this part of the code base, then it was fixing this bug, and then it was understanding this part of the code base. However you sort of like decompose the problem is sort of up to you, and we're curious, like the variety of, ways people are going to decompose the problem, but then you should just describe the process for each of those subcomponents, okay? So try to be as descriptive as possible with the code navigation, code comprehension techniques you use, the specific like Google queries you use. I had a question about can you use ChatGPT? You absolutely can use ChatGPT. That would be something also to include in the process journal, maybe screenshots of your conversation or like a high-level description of what you asked and what you learned from it. Yeah. Remember, all online sources are like totally free to use. And we kind of like encourage that. The next lecture is going to be talking about how to use some of these online resources. So don't be like, oh, I shouldn't include this because, it wasn't something we learned in class. Like, please include everything you use. All right. Any questions about any of this? The process journal, project 2, group project? Okay, awesome. Glad we got those done in a reasonable amount of time. So today's plan is going to be wrapping up diagramming. I think we sort of rushed through it a bit. I want to make sure diagramming is a very important concept. Same thing with creating and maintaining documentation. It's going to be important for the group project as well. So I want to spend time on that. And then today's lecture is going to be about using test cases for comprehension. Okay. So let's wrap up diagramming. I want to give y'all a couple practical tools for how to actually create your own effective diagrams. So one that I want to show, let me reopen my VS Code, is an extension called draw.io. Okay. So again, you can access your extensions through these little blocks over here. And you should be able to search for it. You don't have to do this in class. We're not going to do an activity on it. And if you prefer a different, diagramming tool, totally feel free to use that. But I'll just show in class right now. It's called draw.io. And the way that it works is you can actually just make. Oh, sorry. This is the class website. Let me open up the code base. So the way it works is that you would actually just create a folder, maybe called diagrams, called figures or something like that, and inside your code base, wherever you want the sort of subfolder to be, and then you'll create a new file that just has a .draw.io extension, okay? So I've already created one. Let's just do format region.draw.io, okay? And then this will as long as you have the extension installed and enabled, it'll automatically realize that you are trying to create a diagram because of the file extension. And then here, it's pretty similar to if you've used Google Sheets or something to just create any visualization for a class or something. You can just drag and drop rectangles. You'll want to put specific class names, or you want to list specific method names underneath it. So let's just do format region, and then maybe you'll want to list methods here, maybe list some methods here, and then you can connect it to others. Let's see, actually, I haven't. Awesome, yeah. So you can connect it to others, and I think you can even modify the start and end. You can create, the specific UML diagrams that we discussed last time. You can have maybe your own convention for it. I won't spend too much time belaboring this point, but this is just something helpful that you can have in VS Code, where you'll already have access to the code as well. So it's very easy to sort of refer back to the code and then create the diagram of interest that you want. Okay. Again, this is called draw.io. That's the extension on VS Code. Yeah, draw.io. Okay. And then yeah, I think last time I had shown pi and source, but the image it created or the diagram it created was like not very helpful at all. And so I just want to show a better example using sidebar.py to show that it actually, can be useful. So last year when we had done project 2, we shared this tool, okay, pi and source, and then for the diagram, a lot of people just like did this, took a screenshot of it, and submitted it. To be clear, that's not really what we're looking for the diagram for project 2, okay? This, and sort of like the point I want to make with pi and source is that this will show like everything in a certain file, okay? And again, I can't zoom in more because this is not the paid version of it. But essentially, it shows, all the classes that are in the specific file that you imported. So there's like the base sidebar class, there's the line numbers class, and the shell sidebar class, right? And then it has some of these, you might have noticed there's these things called delegators. We're going to talk about that in the next class. But it looks like, these things use the different delegators, and they have this specific relationship where line numbers is like base sidebar is a base class that line numbers sort of uses. So there's actually a parent-child relationship. But I just wanted to show that this is sort of like a static code analyzer that takes in just the text of the Python file and is able to recognize the relationships between the different classes. Okay. So this I think is helpful for you to just use as like understanding at a high level what the relationships between these different classes are, not necessarily as like a final product for the diagram that you would eventually want to include in your design document or for creating documentation, okay? All right, and then we had wrapped up, oh, sorry, question.
So what would you add or change to make this better? What would you want?
Great question. I'll actually get to that right now. So if you remember last lecture, we had done an activity where you would draw out a diagram to like show the relationship between line numbers, base sidebar, and shell sidebar, right? So one sort of approach here, and there's actually some tips for creating documentation that I'll get to in a couple slides, but for this specific example, okay, and again, this is like somewhat subjective, there's no right answer. I did make this, but this is for like a very specific like reason for the documentation, okay? So this is just to show like the relationship between those three classes. You can see that there's like a lot of information that is that's not here, right? It just has like 3 different lines, maybe a couple like comparison points. It says that edit win is like edit win variable is an editor window object, and line numbers, it's pi shell and shell sidebar. There's just a list of which delegator it uses, and again, you might not know what a delegator is, that's totally fine. And then this difference between update sidebar text and update sidebar, right? And then it also gets across the idea of like a parent-child relationship, that line numbers is a child of base sidebar, and then shell sidebar is a child of base sidebar as well, okay? So the point here is that, and just to emphasize this, there's like so many more actual methods in like base sidebar, and line numbers only uses some of those. There's this relationship with TK text. Let's actually just get into this now. So anytime we create documentation, there's like a lot of sort of like communication principles that we need to keep in mind, okay? So this is like a compilation of some tips from like my experience, like Gerald and Jerry, who co-taught this class last year, are sort of like collection of tips. And then also just from reading some different like opinion pieces online, this is kind of like some helpful tips for how to create good documentation, okay? And also specific to diagramming and like writing documentation, okay? So the first one is sort of the point I'm getting across here, is that almost like every paragraph or every diagram that you'll create should have like a clear objective and purpose, okay? So it's pretty rare that you would want to have a diagram like this be part of the official diagram, of the official documentation, because this is maybe a bit too generic and uninformative for someone who's like onboarding to the code base and needs to understand like a specific part of what's going on in this diagram, okay? instead, you'd want to maybe have, so you might be tasked with like creating a design document or just writing up documentation or updating documentation for a current part of the code base. That is a very great time to ask questions to your manager, your coworker, whoever's like asking you these questions. Like, what is the point of, like, what do I want to get across with the documentation, okay? Is it for an end user to understand, like, how can I actually use this application? Is it for a, coworker or a developer who needs, like, a high-level introduction to this part of the code base? Is it for somebody who's going to be testing my code, who just needs to know, like, the expected inputs and outputs? There's, like, I just listed 3, but then you can imagine so many different sort of like use cases for documentation that's going to impact how you create it, okay? So the clear objective is really important here because that's going to impact what we actually include in the documentation, all right? We also don't want to make assumptions about the reader's knowledge. Maybe you want to include some necessary like background domain information that's going to be useful. Maybe you can sort of direct them to another part of the code base that uses similar code structure or code style. Using diagrams to abstract code is really helpful, or having actual screenshots of specific code snippets is really useful. Maybe you don't want to include the entire class, just include a snippet of like 2-3 lines of code that is maybe very important for the reader to understand maybe the broader like method or class, okay? The 5th thing is keeping the user experience in mind. So this kind of relates to understanding the impact or purpose of the classes or the code that we've written, right? Right now we're working on idle, which is like a graphical user interface, right? It has some actual like output that you can see. You'll make changes and it'll impact the actual like prompts, or it'll impact the features. That might not always be the case where you can like visibly see the code changes like in the final application, but you're going to want to always relate the code to the ultimate like end product, okay? So there's understanding the code structure, like understanding that there is something called shell sidebar, but then understanding like the relevance of shell sidebar in terms of that being like the main implementation of the Python shell in idle is pretty important here, okay? And then finally, this is maybe just a general writing tip, but be concise and to the point. Don't repeat yourself. Maybe have good formatting. Maybe I don't need to belabor that too much. But this is not exhaustive. There's definitely more. And I think there's probably several rounds of feedback that you'll get on creating design, like documentation. In my internship experience, I interned there for 3 months. The whole first month was just creating a design document before writing any code. Before really like understanding too much of the code base, a lot of it was writing a design document like what y'all are doing in the Project 2 checkpoint, where I have like things that I didn't even imagine would be a big deal, were a big deal. Like specific fonts to use, specific arrows to draw between 2 classes, like colors of different classes, color schemes, like these things that you might think are a bit unimportant, like a classroom setting, like I just need to get a deadline due, I need to get the code working. These things are like very important in industry, because something that is very common in industry is that people will work someplace for a little bit and then leave, and then whoever's next has to sort of like pick up from where that previous developer was working on, and that's when stuff like documentation and project management becomes very important, okay? And that like costs a company money when they have to like spend more time onboarding people or catching people up. So there is sort of like a profit incentive here, but this is also just good techniques for code management and documentation. All right. So let's actually do the first activity here, which is just going to be creating a code explanation for the relationship between base sidebar, line numbers, and shell sidebar. Okay. So the activity here, like the maybe full extent of the description is this, like describe the purpose, and maybe let's say like describe the purpose and relationship of these classes as they relate to the user experience on idle, okay? So this is a bit vague and generic. I don't have like an exact right answer or a link or something, but I think let's do this activity to where you just have to write up the relationship of these 3, and then we'll take a look at some of the responses, okay? Maybe limit it to, just like 1 paragraph, not more. I don't think you need more than like 6 sentences for this. But let's take a few minutes to do this and see the variety of of descriptions I'll create. Yes, yeah, this is the same thing that you drew a diagram for. The sort of important point here is that with a diagram, you want to accompany it with a description, and so the idea is that this would sort of go hand in hand with the diagram that you written earlier. Yeah. I'll maybe make the next step red. So there's 40. Okay, maybe take another minute and we'll wrap this up. Maybe we'll go over one or two of the responses.
Oh, wait. There was one bit on here.
let's wrap up in the next few seconds here. Okay, so I'll just start going over this. Maybe you can wrap up the last sentence there of your explanation, and then we'll just go over a couple of these. So, like I mentioned, I think there's no right answer here. I do think there were a couple that might have been a bit short. Like, for example, this one. Sorry, not to point it out too much, but I just want to say you probably want to include a bit more information. I think at the very least, a description should include the parent-child relationship between the classes. And then also, importantly, we want to relate this to the user experience. I think it's very useful to talk about base sidebar as more of a generic class, and then we have these two child classes that are using the attributes from base sidebar in specific cases, right? For line numbers, it's there for the editor window, right? To show the line number in the left sidebar. Importantly, it's only displayed when the user has the line numbers option, but the code is still executed whether or not that option is enabled, right? And then same with the shell sidebar, that is sort of a realization or the implementation of base sidebar for the Python shell, okay? And I think some of these lengthy descriptions are pretty helpful. For example, I saw someone talking about an example of the update font method. I think this is something that's a very helpful. Having a couple of specific references to update font, update sidebar text, or update sidebar width are pretty useful here to help. Remember, this is for a future developer, right? So we shouldn't be worried about being too technical. In fact, I think we want to be a bit more technical in this description, right? But if this was something that was, we wouldn't have this task, of describing these classes for a user experience. But if it was maybe for a manager, so a lot of managers might not have so much technical background. Okay, I think probably the good ones do have a strong technical background and maybe business development skill set. But you also want to keep in mind who's reading this and what their sort of technical familiarity with the code base is, and that's going to impact how much you go into detail about parent-child relationships, about interfaces and abstractions and stuff like that. Okay. Yeah, I think I'll probably leave the activity at that. The idea here is more for you to think about some of these different factors that go into creating a description. And hopefully, we went over a few important things that are helpful in this description. When you go over, when you do project 2, 3, and 4 and have your design documents, we'll definitely be sure to leave some feedback on your description and your diagram so that you can sort of know how you're doing in terms of the technical communication aspect of it, okay? And importantly, this technical communication is going to be something that's present in the rest of these projects, right? In the group project, you're going to have an actual presentation where you'll talk about your code changes. Maybe you'll demo some of the code comprehension techniques for your new task or for your new feature. And then I do just want to point this out in the schedule. You're going to have a code walkthrough presentation, okay? So these presentations, this happens so much in industry as well, where you'll have to actually prepare a slide deck and have good visualizations to explain the progress you've made on a specific feature. So this is going to be, I think, in week 9 of the class. You'll have to do something very similar with your project team. You're just going to pick an existing part of the code base that we haven't covered in class here and give a sort of technical explanation of how that code works, maybe show some diagrams, etc. Okay? All right, let's get into today's topic, which is test cases for comprehension, okay? So I want to qualify this, that this lecture is just going to be about using test cases to understand the code, the implementation, right? The development code. We're gonna have 2 lectures just about unit testing, principles of unit testing, code coverage and stuff. in maybe like 2 weeks. But the purpose of this is just going to be about how can we actually use test cases to understand the code better, okay? So I promise you we will still cover a bunch of activities related to like actual testing. So we're gonna start with an activity here. First, let's see how much time. Okay, we're doing pretty well on time. So I'm gonna show you this feature right now, and then to start, I'm just gonna have you find the feature and try to understand the expected input and output, like the expected behavior of this feature, just using like experimental code changes, code navigation. If you want to create a diagram or something, just what we've already learned so far, use that in this activity, and then later I'll talk about tests and how we can use tests to understand this feature better. And so there's actually more slides here that are somewhere else, but I'll copy paste them in once we actually do this activity because it sort of shows the answer. So, okay, let's open up the terminal here and let's run this. So the feature I want to show. All right, when we have the Python shell open, and let's say I do like print hello, and then I'll have like print world. So what you can normally do is like press the up arrow key, okay? Like what I just did is I pressed the up arrow on my keyboard, and the cursor just went from like down here to up 1, okay? If I press up again, it also just goes up. What you might be used to, and that like what you've seen, for example, in the command line or like the terminal in VS Code is if you have like a history of things that you've done. So like let's just say. Let me make this bigger. Whoops. And do that. You can normally just have like ls cd ... ls, and then you can actually just see the history of commands just by pressing the up arrow, right? In idle, we are not able to do that. Okay, the up arrow just moves the cursor. It doesn't actually show the history. Okay, but if we do shell previous history, okay, we can see that there's a different keyboard shortcut for seeing the history in the shell, okay? So this one I think it's Command P or Control P in a Mac. So if I do this, it does print world and then it does print hello, okay? I'll leave it at that. There's some nuances with this, but I'm gonna leave that for the activity right now. Find where this feature is implemented in the code base and then use like code reading or some experimenting to try to figure out the specific behaviors regarding this. Like what are some specific commands that maybe would or wouldn't be included in this history? How does it access the history of commands? Just take like maybe 4 minutes to try to do this using the conventional techniques that we have already done. There's no Google form for this, so maybe just experiment on your own. We'll give y'all a couple minutes, and then we'll have you talk in groups for the last part of the activity. Okay, let's just get with like the person next to you and just discuss like what you've done so far and what you've figured out. Importantly, let's try to cover that like step point A. Like, what were some things that you know are sort of like edge cases that this code handles? Alright, so let's actually just like reconvene now. So hopefully you were able to use some of these techniques before and try to at least like find where the actual implementation code is. Maybe I'll just show that right now. So it's gonna be in something called history.py, okay? And this is like it's I think called history because it's the history of the Python shell. And specifically, I think the logic for it is stored in like fetch and store. So the method called fetch on line 41 and then store on line 90. So with reading some of the code, maybe we can get some understanding of what is and isn't included. Like for example, we will only like, I guess, add something to this variable called self.history if the length of source is greater than 2. So maybe if something is only like 1 character long or 2 characters long, it's not going to be, you know, in the history. To like sort of confirm this, we're maybe not so sure just upon reading this. There's this weird maybe like try except thing. You could actually just like try that as well. So maybe if we just have, you know, like 6. And then if we try doing the previous history, which I just did, it doesn't show up as, you know, because the command was maybe less than a length of 2 or less than a length of 3. So I'm gonna leave it at that for now. We're gonna come back to this specific code and the test cases for it. I'm just gonna go over maybe some examples of how to use test cases for comprehension, and then you'll redo this activity using the test cases for this, okay? So to sort of like as a primer, all the code for the idle-lib codebase is here in idle_test, okay? And what you'll notice is that there's like a bunch of files here that actually correlate to the exact like development code that we have in the regular codebase. So you can look here, we have, you know, autocomplete_w, autocomplete, auto-expand. Under idle test, we have the same code, but just like a test file for each of those, okay? And just like we would do in a regular code base, so if you remember like on the first day of class, maybe the second day of class, I asked like where I think a certain feature is located, and one of the like good approaches was reading the actual like readme of the development code, right? This is now the regular development code. If you have like the readme, it talks about like what each of the files is and like a high level like quick description for how it relates to like the actual user experience, okay? So I'm gonna maybe like more formally assign this later, but I think reading this readme.txt is super useful for just understanding the set of tests, like how testing works for the idle lib code base, okay? It's actually maybe a somewhat long document that talks about why we have a setup and tear down class, like how to maybe run test code coverage to see like what % of lines are actually covered by test cases. This is typically like a starting point for any time you're going to work with the test, okay? It's just like reading the actual like documentation. And remember, like I think I mentioned this earlier as well, that in some companies there will just be like a team dedicated to testing, okay? So like what we have been doing in the class so far is just focusing on the development code. You know, depending on your role at a company, you might just be like a test engineer, and so you would be working, you know, pretty much fully with the set of test files, okay? So that's another thing maybe we should get out of this mindset that we've had more in undergrad, like previous undergrad classes where you're writing development code. You know, a big emphasis like effective software engineering is focusing on the test code as well, okay? You can see that there's like as many test files, maybe even more test files than number of like development files, okay? So let's see what we can do with these test cases. So for this demo, I'll just do the test of the sidebar class, okay? So you can open up test.sidebar and maybe like follow along if you want. You can see we have like a bunch of these different import statements. These are just regular things that are imported from the actual development code. So we're importing, you know, a couple functions from idlelib.sidebar from the sidebar.py Python file. We have a class called dummyEditLin. Let's look at maybe like the line numbers test, okay? So we do a quick look at the outline view. We'll see we really only have like 2 test classes, line numbers test and shell sidebar test. So let's look at the line numbers test. You know, a lot of this might be things that you have to do a bit of like code reading and making a few deductions, okay? So it looks like we have a class called setUpClass. We have this annotation that's called @classMethod. You might not know what this like annotation means. That's going to be the focus of next lecture. We're going to talk about how do we learn things about the code base that we just see, but we don't really know what it's doing. Maybe we're setting up something called a text frame using tk.frame, and then we have this like tk prefix for quite a few of these objects, a tk.text thing. And I think we actually looked at this last class, but this is a tkinter text widget, okay? If you've already completed project 2, you've probably run into this and maybe start to recognize like how important it is for the idle code base. Maybe we can look at just some of these like method names. So it looks like we have something called get sidebar text contents, okay? And it looks like this is just a method that returns, I don't know, maybe the contents of the sidebar from the beginning until the end. Again, we're kind of like making some deductions here, but we are maybe starting to get some understanding of like how we can access certain pieces of information that we want to actually compare, right? Here we have something called assert sidebar and lines. So just a quick word, I think most of y'all have seen this assert keyword before. Assert is used, I think in the Python test suite, like PyUnit we have these like assert equal, I think there's other like assert null or assert none. There's these different assert statements that are just returning true or false. It'll return a Boolean value based on whether the parameters passed in here are I don't know, the same, or if they sort of like match with whatever the method call is. So here we would have assert equal. You'd return true if the first parameter is equal to the second parameter. Okay. So hopefully this is not too novel. You've seen test code before, but now we can actually look at the names of the functions. Okay, so something that's really helpful in the testing, like when you write your own test and when you're using unit tests for comprehension, naming is going to be very important because you'll have multiple methods that test the same, like you'll have multiple methods that test the same class, but you'll be wanting to test very specific functionality or very specific features of a class, okay? So for example, here, let's do like test insert, okay? what we can maybe start to take away from this is that we are only testing some like insert method or insert function for the line numbers, okay? So let's just like take a look at how this actually functions. So we have self.text, and maybe we can see what self.text is. This was just the tk.text thing that I sort of alluded to earlier. It looks like we are just inserting, we have like a parameter that's insert, and then we are inserting something called foobar, okay? And then we have a self.assert text equals. So again, you can navigate the test code just as you would with the development code that we were looking at earlier. So I can actually click on assert text equals, and it looks like it's just taking in a parameter called expected, and it's just asserting if, I guess, like everything in the text widget or the text object is the same as what we passed in here, okay? Let me go back out. So it looks like, this is kind of interesting actually. We have, let me get rid of this. We have just inserted like foobar, right? But then we're checking that the text equals foobar \n, okay? Does anybody know why this is happening? Not yet. Okay, that's totally fine. This is maybe something that, like, maybe you could already just see the value of this, right? We know that there's some behavior that we didn't sort of realize or perceive before, but by looking at the test cases, we sort of do know what the expected behavior of like the idle sort of like the editor window should be, okay? And then it looks like we have an assert statement for sidebar and lines. We can maybe just guess by reading that this is checking that there is, one line in the sidebar. And that should make sense, right? Because all we've done is add one line, and it should just, then be one line that says foobar, right? And then we have this other thing that says assert state disabled. This maybe we haven't really covered yet. I think this will probably be part of next lecture when we talk about what, like learning about things that we don't understand. But it looks like maybe from here, we know that there's something to do with the configuration of the editor window or of the sidebar. And then let's just take a look at this, tk.disabled. We've been seeing this like tk thing before, and we know that it relates to tkinter. Just by like doing a command click into it, so going to the definition, we're taken to this like constants.py file, and it looks like we have like a bunch of constant variables that, like, this whole file is basically just like specific variables and like the raw text like value of it, okay? So we have like the constant variable left is just equal to the string left. That's, not uppercase, lowercase. So I'm saying these things, and this is going to be kind of relevant to project 2 and 3. So I just kind of want to encourage this idea of when you don't really know something, just looking through it and exploring it is very valuable for just like connecting different parts of the code base, okay? So let's go back to, okay. All right, so maybe just to like get through this like insert thing, again, we have like, we're inserting hello \n twice, okay? So we're having like, we still have the same foobar from before, and I think we had, a previous insert where we had and insert a new line and then foo, right? But then we have like hello \n, hello \n, and then again, we have this like ending \n, and then we're just checking that we actually have like 4 lines here, so this maybe is kind of making sense. Then we have like test to delete. So it looks like we are, again, inserting foobar. We're checking that, foobar is there. And then we have like a delete where we're deleting. Again, we have like these parameters here that we don't exactly know what it means upon reading this. We're deleting 1.1 and then 1.3, right? But then by reading the next line of code, we can sort of understand what the text.delete method is doing, right? It looks like we just got rid of the OO, right? And now we just have fmar. So maybe we can start to make some conclusions that this delete thing deletes characters from maybe 1.1, so maybe this is like the first row and the first character, up until the first row and the third character, okay? And so maybe we'll start to understand whether it's like inclusive deleting or exclusive deleting, you know, are we actually deleting the third character or are we leaving the third character and just deleting up to? These are some sort of like realizations I think that we can make from this, like reading these test files. So here's what I really wanted to get to then, right? As we like keep reading the like the test delete method, we come across this. So we have a comment here that says deleting up to end doesn't delete the final new line. Okay, so let's just see what this code has actually done so far. It looks like we've eventually like added a couple lines. So we have like fbar foo underscore n foo, or sorry, \n, and then 2 new line characters at the end. Okay. So this is like where we're at right now in the test case. We're just like, you know, adding and deleting things and making sure that the text is like updating appropriately. But then here, when we delete 2.0 to end, it looks like we're deleting, let's see, just this. But we still have, you know, the 3 characters at the end. Okay, so even though this new line character seems to be in the second line, okay, the second row, when we do 2.0 to end, we don't actually end up deleting this new line, okay? And then you can actually see there's a comment later that text widgets always keep a single new line character at the end, okay? So this is maybe something that maybe a lot of y'all don't recognize, like why this is even important. It might seem a little bit like unnecessary to go into so much detail about this right now. But I think for project 2, once you start to see like what exactly you need to do to get the total number of lines in the editor, this will become quite relevant, okay? And I also think like I chose this specific like test file to go through because I think if you're a little bit stuck on project 2, I think reading through this specific test file will be incredibly helpful in overcoming like one of the main obstacles in project 2, which is like how do you find the total number of lines in the active editor, okay? So hopefully you maybe can rewatch the podcast and see like some of the things that we've explored here. But I think you know, going through a couple of these will be very useful for that project, okay? And then just to maybe connect some dots from last time, remember we had talked about the sidebar width with the new line feature. So remember when we have, you know, like line numbers 1 through 9, the width is only 1, and then when we had, you know, 10 through 99, the width of that sidebar was 2. It looks like just by reading this single like test file or test class, we can actually like understand exactly how that feature is supposed to work. So, for example, when we have, you know, when we insert foo 8 different times, we want to make sure that there's, you know, 9 lines, and we want to make sure that the width is actually 1, right? And then when we add another line, we want to make sure that there's 10 lines and the width is actually 2. So a couple takeaways from this. One, you know, I kind of like went through this almost line by line, and it got a bit repetitive. Like, okay, we're asserting that the text equals this, that sidebar is, you know, this number of lines, that the state is disabled. Like, think of like how many different things we're actually checking, just like in these like 5 lines alone, right? The thing to sort of take away here is that test suites are going to have like so much information about all the different things that are going on under the hood that are more than just like what we observe in the like final application, right? By reading the test cases, we now have like a much sort of like better understanding of all the things that are impacted by just like adding in foo bar to like the first line, right? We know that, you know, the tech, like this like editor window or like the text variable should have, you know, this foo bar and a \n. We now know that, you know, you can actually do this delete command and sort of delete up to, but not including the third thing. We, you know that there's going to be some update to the number of lines in the sidebar. We know that there's going to be some impact of this state, okay? So there's a bunch of assert statements, and it's a lot to sort of like read, but it's very useful in understanding like what different things are impacted by, you know, the code of interest here, okay? Are there any questions about just like how we can sort of use test cases for comprehension? Main things are pay attention to the assert statements, you know, read some comments, and definitely the titles of these different tests are quite useful, okay? So now I'm gonna have y'all revisit. Oh, whoops. So these were the two that I had deleted earlier, but I'll put back in. So for today's activity, we'll just wrap this up in the last like 7 minutes of class here. We'll have you all look at the test cases in test_history and read through the store test case or the class and answer this Google form question about the specific behaviors that the history class now handles, okay? So you did the first thing by like reading and maybe making experimental changes. Now use the test cases to come to like a little better understanding of it. Do maybe 2 more minutes to wrap up the answer here, and then just want to quickly go over it. Okay, maybe like 30 more seconds to wrap it up. At 48, I'll start going over this very briefly. If you need to, you can submit this a bit after lecture as well, and then we got a bit close to the time here. And so if you want to write out something a bit more thoughtful, you can wait as well. Okay, so let's just go over this very quickly. So if we go to test_history, the main thing here is you can actually just see so hopefully you recognize that there were a couple like global variables kind of defined in this test file. And like this maybe is just like belaboring the point, but you can see like very clear the inputs and how like through the assert statements how this is supposed to actually respond to it, right? So it looks like if we call the store method on just the command A, okay, like when I just typed in 7, it looks like the expected value of history, which is going to be the sequence of like past commands that we've already used, should be empty, okay? And then interestingly, it also looks like when we have like a couple spaces before the A and a couple spaces after the A, and we have that as the command, it should still be empty, right? And you can actually like sort of align this with the code that we have written before, or we had read before. It looks like there's like a strip command, okay? When we run strip, it gets rid of the white space before and after a specific command. But if the test file is a much easier way to sort of digest this because we don't have to really think through and trace the code. It's very easy to just sort of like see this visually in 3-4 lines of code, okay? There's also more stuff about how it handles duplicates and how it resets. There's this is a bit harder to understand, but if you want to like explore this like pointer variable and how this works in the actual implementation, feel free to do that on your own. I think we'll wrap up the class now. Just a couple of quick reminders. Project 2 is due in 1 week. Please come to office hours this week if you're sort of stuck on like how to access some variables. I'll just leave it at that.